This video will provide the solutions to the second problem of the review sheet for the quiz. Daphne pleucaria is a water flea, a small crustacean that lives in lakes and is a major food supply for many species of fish. When fish are present in the lake, they release chemicals known as pheromones that induce water fleas to grow a long tail spines that makes them more difficult for the fish to eat. One study of this phenomenon compared the relative length of tail spines in the Daphne pleucaria when pheromones were present to when they were not. Below are the data on the relative tail spine lengths measured as a percentage of the entire length of the water flea. So the question is, do the data provide convincing evidence that the mean relative tail spine length of Daphne is longer in the presence of fish pheromones? Okay, so we're dealing with quantitative data. We also are looking for a hypothesis test, and it's a one-tail test because notice in this line over here it says it's longer. So we know it's actually a right-tail test. And we actually have two independent samples. And so we're going to be performing a two-sample t-test. And the very first step of this process is to define the parameter. So the parameter is defined as mu1 minus mu2. That's different from problem number 1 where it was mu diff. Here we're looking at the difference in the means as opposed to the mean difference. So the context is true difference in means of the tail lengths of Daphne when pheromones are present and when they are absent. The next step is to actually see if our conditions are met. So we're going to take a look at that now. For the first condition, we have to actually assume we have two independent random samples because we don't know for sure how the study was conducted. So we'll make that assumption. For the next condition, we're going to make the assumption that there are more than 2,140 fish that release pheromone and 1,500 fish that do not release the pheromone. That's the 10% condition. For the third condition, we can say since both samples have sizes greater than 30, we can apply the CLT and approximate the sampling distributions with a normal model. Thank heaven for the CLT. We now have to state the name of the procedure, and we can do this right in this line. So let me star it. Since conditions have been met, we can perform a two-sample t-test, and notice I've left this blank because we're going to let the calculator determine the degrees of freedom. If you didn't have the calculator, what you would do is you would take the smaller of the two sample sizes, in this case 152, and subtract 1 from it, but it's always better to use the results from the calculator. So we're up to the calculation steps, so we're going to do that right now. So we're dealing with a t, again, because we don't know the population standard deviation. And so the formula would be the statistics minus the parameter, which is almost always 0. And I just realized I forgot something important. What I forgot is to write out the null and the alternative hypothesis. So we're going to fix that right now. So our null hypothesis is mu1 minus mu2 is equal to 0, that there's no difference. But we're expecting that the fish present with the pheromone present is going to have a higher length than without when it's absent. So that would be mu1 minus mu2 is greater than 0. So I just fixed that part of it. And so now let's go to the rest of the calculations. So again, this is the general formula, and then for the standard deviation, which you can find from the formula sheet, it's S1 squared over N1 plus S2 squared over N2. So we're now going to substitute into the formula 37.26 minus 30.67 minus 0 over the square root of, and again, we can just take it directly from the table, 4.86 squared over 214, that's N1, plus 4.19 squared over 152. And so now we're going to actually go into our calculator. So we're going to hit Menu, Statistics, Stat Test, and it's a 2-sample T. Hold on. We don't have data this time. We're using summary statistics, and we press OK. And then we just start typing in the values that we had before. So this would be 37.26 for the mean, 4.68, 214. For the second data set, 30.67, 4.19, and 152. And then we scroll up, or for me, scroll down rather, and you just have to make sure that the alternative hypothesis that you choose is correct. So in this case, we want the top one, mu1 is greater than mu2. As far as pooling goes, the only time we're going to pool is with the 2 proportion z-test, nothing with the means. And then we press OK. We end up having our values, which we're going to pull off in a minute. And what's really important is to make sure to pull off the proper degrees of freedom. So we can fill that in now. So let's go back to our sheet. Now, we can plug in or substitute in the proper degree of freedom, which is 345. I now can fill in what my t-statistic is, and my t-statistic turns out to be 14.119. When I look at that, I know already that I'm going to reject my null hypothesis because this is over 14 standard deviations away from the mean. We're going to calculate the p-value right now. So I know that the difference between the means, when I actually calculate it out, is going to be 37.26 minus 30.67 is actually 6.59. So the p-value is this area to the right. It has to be as great or greater than that test statistics. What's that likelihood? So the notation you're going to use is x bar 1 minus x bar 2. That's the evidence. What's the chance that I got a difference of 6.59 or higher? I converted that to a t-statistic using the formula. So what's the chance that your t-value is greater than 14.119? And normally you could just put the p-value down, but I want you to have practice calculating the p-value. So that's, you're going to use TCDF, the low as 14.119, the high as 9E999, and the degrees of freedom is that really high value of 345. When you actually enter that into the calculator, you get a p-value of 2.4 times 10 to the negative 36. That's a really, really, really small number. Be careful, never write 2.4. Sometimes people forget about that E negative 36. This means there are 35 zeros before that 2. So this is essentially 0. So this value is so small, it's going to be less than any significance level that you choose. So if I chose 0.01, it doesn't really matter. Since the p-value is less than a significance level of 0.01, we reject HO. We have convincing evidence that the mean relative spine length of Daphnia is longer in the presence of fish caramons. And so we finish the problem.